So our next speaker is Wojtek Wrona, and it's a really nice proof that attending conferences can influence your thinking, which can influence what you do on a daily basis, which then can lead to a great presentation. So, ladies and gentlemen, let's welcome Wojtek.
Hello, hey. So my name is Wojtek, and apparently I'm a crazy person. At least that's what I've been told yesterday. And you know why? Yeah, well, he already said that I'm using SQLite on production. Not only that, I actually migrated from Postgres to SQLite, and I like it. I don't know why they let me in here, but so maybe let me quickly tell you why we decided to do that. So I'm at lead at a small startup. We have 8 developers total, only 3 of which are backend developers. That includes me. My attention is split between quite a few things, so that's not that much velocity. Our race app has 18,000 lines of code right now, twice as many lines of tests. We have a mobile app, we have a web app. There's quite a lot of work to do. And as it is at startups, there are tight budgets, tight deadlines. We don't have that much time for optimizations. There's a lot of work to do. We don't have a dedicated DevOps team, dedicated optimization performance team. Last year, I attended Wrocław, and I was influenced by the SQLite influencer, Steven, who had a great presentation. And I thought, well, that may be something we could use. We could use it. That could work for us. But I wasn't fully convinced yet. But then, Race improved support for SQLite, largely thanks to Steven's contributions. Then they released all the solid stack gems, solid cache, solid queue, solid jobs. And it started looking pretty solid. So yeah, we decided we may test it out. And yeah, so why did we actually decide to take the step? Steven yesterday had pretty great presentation where he outlined some great advantages of SQLite. But let me just quickly tell you why we thought it will work for us. So first of all, SQLite is an embedded database, which means there are no. Well, maybe let's pause on that. What does it mean that it is embedded? If you look at SQLite's how SQLite is built, they actually concatenate all of their source files into a single large file, which then is basically compiled into a gem, which means you don't need to install anything external. Once you install a gem, you have a database. You don't need to start a Postgres server. You don't need to start a Redis server. That means, among other things, that latency is basically non-existent. As Steven said yesterday, N+1 queries aren't really an issue, or not a big issue at least. So you don't really need to spend nearly as much time on optimizations as you would in Postgres. And vast majority of our queries for our application are reads, so it seemed like a pretty good fit. Then we also run a mobile application, and we do end-to-end tests for mobile applications, for our mobile applications. And end-to-end tests aren't so simple for those. Well, you need to run a simulator with iOS. It's not very trivial to set up a backend for those tests. So we were running a test server with a persistent database, which meant that we could only have one end-to-end test running at a time, because we only had one database for the test. With SQLite, we're basically just copying our database when each test starts, and each task run can have a separate database, which means we can run as many, well, maybe not as many, but a few parallel tests, and it works. Bundler is, we just do bundle install, you have everything you need. You have your database with the solid stack, you have your cache, you have everything you need just after installing Bundler. And with that, we decided to actually get rid of Docker. And don't get me wrong, I think containers are great, but well, there is some overhead with managing Docker. You need to, well, if you want to deploy using Docker, do you want to use Docker Hub or something like that? Do you want to? There's a bunch of decisions you have to make, a bunch of things you need to maintain. Without Docker, it's well, with SQLite, we just decided that we don't need it anymore. And with that, our deployments became very, very simple, actually, because well, you only run one server, you run bundle install, and that's it. Yeah. And if deployment is very easy, maybe we don't. Also, we are using render. I don't know if you don't know what render is. It's like Heroku, but cheaper. Yeah, I mean, it was pretty simple, but well, we needed some additional dependencies. So we actually were using Docker on render. They are supposed to cache your builds, but it was still very slow. There, you need to set up all of those. Postgres, right? You have to figure out how big Postgres dyno do you need. With this simplified model, we could very easily actually migrate to a single server. Right now we are using and that is that allowed us to slash our costs by quite a lot. Right now we are using Hetzner, and we are deploying it with Hatchbox. If you don't know what Hatchbox is, it's like Heroku for your own server, but you pay $10 per month, and that's it. And they handle environment variables, they handle team access, they handle the deploy hooks with GitHub. They do everything that Heroku does for you. I mean, they don't have those plugins that Heroku does, but I mean, we don't need them with SQLite. So I did this very quick comparison for the price. So right now we are using a small Hetzner server with 16 vCPUs. To get the similar amount of vCPUs on render, we would have to pay like $650 a month for what we get for $77 on Hetzner right now. And that's assuming that you're okay with running 14. Like here, I assume that you will have 14 small dynos with one vCPU and one dyno with 2 vCPUs for the worker render. And that also has some downside. I mean, you have to rely on their load balancing, which won't be as performant as having everything on a single node. If you were to use a single big node on render, the cost would basically double. So yeah, that's quite a lot. And we have a few hundred daily users right now. This machine is, we're utilizing just a tiny bit of the performance that we have. So how did it go? The whole migration actually went pretty smoothly. I was the only person working on it. It took me around 3 days to migrate the whole application. Again, we have 80,000 lines of code, so I think it wasn't that bad. And our requests are basically slashed in half. I mean, it's hard to compare because we are using Hetzner now instead of render, so it's not only, you know, it doesn't mean that we just change that ways and that's it. But I mean, yeah, everything is much faster. And yeah, our infrastructure cost just dropped by an order of magnitude. We don't really need to care about DevOps. Well, to be honest, I think Hetzner with a single node is easier to manage than render was, even though render is already very simple. And with that, we have more time to focus on features. We don't need to spend nearly as much time on infrastructure, on optimizations. So how did we get there? Well, so we didn't want to do this big bang strategy as it was mentioned today. We wanted to do a few small incremental steps. We wanted to be able to merge each of the steps, test them, make sure that they're reversible if anything goes wrong. Yeah. So our approach was to, first of all, we wanted to make sure we migrate everything. Make sure we have our migrate everything we can while still using Postgres. And that meant basically migrating our schemas, our types, step by step, testing them, running all the tests, deploying it to staging, testing it, and only after that, only after our Postgres schema was compatible with SQLite, we did the switch. We switched the database router, and we actually migrated data. And after that, we've run all of our tests. We saw what's failing. We fixed those things, and yeah. So the first step was to handle unsupported types. Now, SQLite has pretty unorthodox take on types, but yeah. But in practice, what that means that there are some types in PostgreSQL that aren't available in SQLite. Like say inet or UID or interval or Postgres arrays. And SQLite uses dynamic typing. Maybe let's not get into that too deep, but so how do we migrate? How do we make sure that we can store our data without really having to rewrite half of our application? And we used active record types. So if you think about it, so let's say you use inet, which inet column time which maps to IP address class in Ruby, in Rails. Whenever active record tries to save that data into the database, it actually has to serialize it somehow. I mean, PostgreSQL doesn't really understand native Ruby types, right? So active record has something they call types, which defines how to serialize and how to deserialize Ruby objects into something that the database understands. And Rails actually allows you to define custom types. You just inherit from, or write your own, or you can just inherit from types available in Rails. And yeah, so that way you can tolerate how to serialize those objects, how to deserialize them. And if you do it like that, then most of your application code remains unchanged. Your application doesn't really need to know how your databases are stored in the database, as long as Rails is handling serialization, deserialization. Just to show you how it can look like, here is a very simple example for inet, for the IP address data class. So you define a serialize method, which it can take either already deserialized value or a serialized value. But you just have to, it just takes a value and you have to serialize it to something that your database will be able to understand. And you also have to define what to do the other way. So how to take a value that is the value from the database and deserialize it. After that, you need to tell Rails to use your class for a given attribute, because in the database it's actually stored as a string, so Rails can infer the type on its own. But yeah, that's it. And after that, Rails will use your type for serialization, deserialization. It will also use it for queries. So if you use your Ruby object in a where statement or find by, it will also serialize it properly. You need to change your columns in the database. So you just specify to so for IP, Postgres can actually pretty easily convert them to strings. If you want to reverse that migration, you have to help it a little bit, but it's very simple. It all runs in PostgreSQL. You can deploy it, test it, see if it works, run all of tests, test it on staging. If it doesn't work, you can revert it, and you can do all of that while still using PostgreSQL. One challenge where, so I don't know if anyone uses arrays in Postgres. Oh yeah, a few people. Okay. Arrays are slightly trickier, and we use them quite a bit. Because, I mean, you can serialize arrays to a string if you want, but you wouldn't be able to easily query them for a specific value, right? So we decided to serialize them to JSONs because SQLite does support JSON, and you can actually query JSONs. I mean, an array is a valid JSON, and you can query JSON arrays for a specific value. I probably won't have time to go over the actual implementation of that. I wanted to extract this to a simple gem, but didn't have enough time. So here is a link to where the gem will be soon. Yeah, so as the next step, we decided to go into the solid stack. There is a ton of tutorials on the internet on how to migrate to solid stack, how to use it. You don't really need Redis anymore. Each solid gem uses its own separate SQLite database, so you can run it alongside your Postgres database. Again, you can migrate, put it on staging, test it, see if it works. Another change we had before the data migration were constraints. So we use check constraints quite extensively in our application. And some functions in PostgreSQL differ from functions in SQLite. In particular, casting things like to integer and so on is slightly different, which means that those constraints would fail in SQLite. We decided to just remove those constraints before the migration and add them back after the migration. Actually, ChatGPT is great at translating from PostgreSQL syntax to SQLite syntax, so we just put our DB schema into SQLite and it produces all the migration we needed. So yeah, then we did the actual data migration. With types migrated, with constraints dropped. Our schema, well, we didn't have anything in our schema anymore that SQLite wouldn't be able to handle on its own. So we changed our SQLite adapter, our database adapter to SQLite. We pointed our database yum to a new SQLite file. We created a new database. We've run the RaisDB create, RaisDB migrate, created a database with schema. We used this open source script. We had to slightly tweak it, but it's just a single bash script. You can review it, tweak it as however you want. And after that, we've run our test suite to see what works and what doesn't. It actually wasn't nearly as bad as we thought it would be. But well, yeah, a few things were missing. So before I start, maybe let me tell you that a little bit about extensions. So SQLite is very light, but you can extend it with extensions. There's a gem called SQLine, which bundles a lot of useful extensions that you may want to use, like IP addresses, math, regex, text, and so on. On the newest Rails, I don't think this is actually Rails. We had to switch to Rails main to use it, but in Rails you can specify which extensions you want to load for your database in your database YAML, and that's it. If SQLine isn't enough, you can. There is I forgot the name, but there is another repository with like 100 or more extensions. There are even extensions which use OpenAI from the database, things like that. There's almost anything there. So one issue we had one surprise were iLike. So iLike is used for case-insensitive search. Turns out SQLite doesn't have iLike. What's more, like in SQLite is actually case-insensitive by default, but only for ASCII. So if you use it with, well, why is that? We are pretty surprised by that. And SQLite FAQ, they actually explain that to do to swap case for full Unicode, you would need to include tables and logic that would nearly double the size of SQLite library. SQLite is very tiny. How do you solve it? Well, the easiest thing you can do is to actually install SQLine text extension, which adds all of the functions that operate on a Unicode. You can even alias them to avoid the built-in functions. Though, to be honest, we didn't do that. We used something slightly different. Because there are two things in SQLite that you can do to solve that. So first of all, there is you can specify collate for a specific column. Collate is almost like a comparison function. You can tell your database how to compare two values between two rows. So for columns that are always case insensitive, like email, like we always want to compare emails in kind of insensitive way. Or like you have discount codes, you probably don't want to compare. You always want to not care about case when comparing them. So you can run this migration after adding this SQLite text gem. You can add this migration to add specific collation to your column. If you do it like that, your email column becomes case insensitive when it comes to comparisons. It also works for unique constraints, things like that. If you have columns that are sometimes case insensitive, you can actually, we did that. You can, in SQLite, you can create a virtual stored column. Here we are actually combining first name, last name, and lowercasing it before storing it. If you do it like that, you can index it, which means your queries will be faster. So yeah, so if you use collate, no case, you can just query your column as you would normally do, and your database won't care about your text case. You have, if you use those virtual columns in PostgreSQL, you would do ILike. In SQLite, we just use our virtual column and use either like and downcase the text in Ruby. The text that we search for, or you would use, you can also use glob. Glob is similar to like, but uses those Linux-style file globbing syntax and is case sensitive by default. Also, remember we migrated our array columns to JSON? Well, so turns out it worked while we were on Postgres. But it worked because Postgres has those function for querying arrays. Once we migrated to SQLite, some of those queries stopped working because Postgres was able to use those functions even though we were using SQLite arrays. The easiest solution, there is an array extension, and it would probably work, though we decided to just switch to JSON functions. And again, Steven has a great article on how to abstract querying JSON fields. We just used that. Also, a cool thing so since SQLite is embedded, it runs inside your Ruby process, which means it has access to your Ruby memory, it has access to your Ruby code. Since it has access to your Ruby code, it can call your Ruby code. So if there is something missing and there is no extension available, you don't know how to fill that gap, you can, I don't know if that, we haven't really tried it on production yet, but you can create custom Ruby functions. Functions, you can define both scalar or gray functions. So that's how it works. A silly example, but I created a function that sorts letter in a given column. This is Ruby. If you look at it, it's using active support. It has access to everything I have in my application. And I can actually run it. So here I'm selecting just first names for my users. And if I use my silly sort letters functions, it's returning them sorted alphabetically. You can also define aggregate functions. It's sort of almost like writing reduce in Ruby. Here I'm writing a function. So, when you're defining those functions, you can also define the array of them, how many arguments they take. Here I'm defining a function that counts strings for how many occurrences of a given letter they have. And with that, we can count how many users has A in their first name. Or we can find all the, for us, we're organizing events, so we can find all the events which have more than 257 users with the letter A in there. I mean, it is a silly example, but you can do whatever you want with it. Another difference we had were, so that this was small, but nulls are treated in a slightly different way in SQLite than they are in PostgreSQL when it comes to sorting. So in PostgreSQL, nulls are the highest possible value, in SQLite they're treated as the lowest possible value when used in the order class, order by clause. The solution, if you really care about it for a given query, you can specify nulls, whether nulls should be first or last. I don't know of any nicer way to do it than using our table. Yeah. So we migrated our database from PostgreSQL to SQLite. We deployed it to staging, everything worked, but we found out so maybe let's start with how concurrency works in SQLite. Postgres has a pretty sophisticated row-level locking. There is this, it uses MVCC, which basically allows you to have multiple writers proceed as long as they're touching different rows in most cases. In SQLite, so right now we have the wall mode enabled by default in Rails, which allows you to have multiple readers concurrently, but you still are limited to a single writer at the same time. What that means is, so in newest version of Rails, Rails uses begin immediate transactions by default, which means that whenever you open a transaction, the transaction acquires a reserved lock, which locks your database from writes. You can still have as many reads as you want in parallel, but you can only have one write at the same time. So for typical Rails model updates, when you do like user create, user update, that's usually quite fine because those writes in SQLite, if you're using an NVMe SSD, they're extremely fast. But when you have longer transactions, that may become an issue. So I have another silly example. Let's say we have a transaction that updates the model and then calls an external service. Until the external service returns, your transaction is still open. Your log is still acquired. In Postgres, I mean, this probably isn't a good practice, but we used it in some places because it was a shortcut in a way. If your external call fails, then your transaction will roll back. Your change wouldn't be persisted. And in SQLite, you can't really do that. I mean, you can, but you'll log out your application, and your app will fail. In this silly example, we could just reorder things and do this transaction sort of manually. So call the external service and only update if it's succeeded. But you can't always do that. And one place where you can't do that easily are data migrations. So let's say you have a migration in which in migration, Rails by default wraps the whole migration in a transaction. So you have migration in which here we're updating each user, computing some new status for that user. It may take a while, especially if you have a lot of users, especially if computing the new status takes a while. So for the whole duration of the transaction, your database will be locked. And I don't know of actually any good solution. There's a few things that you can do to mitigate it to some extent. So, you can use raw SQL. That may be just fast enough for you, but in many cases it probably won't. You can disable transactions for a given migration. Then each update will have its own small transaction, which wouldn't lock your database for the whole duration of your transaction, but you're losing transactional migrations. You can not do your data migrations in a database migration, create a rake task for it. So another trade-offs were foreign key errors. In PostgreSQL, if you delete something from or update something in your database and it breaks a foreign key, you get this very clear error. You know exactly which foreign key was broken, on which table, on which row. SQLite's errors are slightly less helpful. You just know which error code was raised, and that's it. And that can be frustrating if you forgot to specify some relations on your model. So let's say you have a user model you forgot to add has many orders, dependents, something, and you try to delete this user from the database. You will just get a foreign key constraint failed error, and you'll have to figure it out on your own. The only thing we figured out so far for debugging those errors is to disable foreign keys, execute the query that breaks the foreign keys, and then you can run this command which will force checking all the broken foreign keys. I will give you some data, but obviously you can't run it on production. You can only really do it on your development machine. So yeah, that's annoying. Another limitation is that you're limited to a single node by default. So since SQLite is just a file or files on a disk, and there is no server, you're limited to the server on which you run it. You could scale it. I mean, you can actually replicate your data into multiple machines. There are tools like Lightstream or Turso has replication. But your writers are still limited to one node. So how do you scale? The simplest thing you can do is to go vertical. Since modern servers are pretty powerful, you can actually go pretty far with it. Especially since SQLite is incredibly efficient. There is no network connections, no inter-process connection. Everything is much faster. And yeah, because of that, you can get a lot of performance from a single large instance. So here's an example. We are currently running our production on 16 vCPU server on Hetzner, which costs around $70 a month. The Hetzner on their cloud solution allows up to 48 dedicated. We are actually running on shared vCPUs. They allow up to 48 dedicated vCPUs with 192 gigabytes RAM. And there are even, I've seen even other clouds which offer up to 256 vCPUs. That's a lot. And those, and if you have a bare metal solution, you have access to the whole NVMe SSD, which are extremely fast. That will be able to handle a lot of traffic. Another thing you can look into is replication. So there's this thing called libSQL, which is an open source fork of SQLite. They're working on quite a lot of things. It has an official Ruby adapter as well, called libSQL Ruby. And they have this thing called embedded replicas, which allow you to replicate your database into multiple nodes. They forward writes to the primary nodes. They make sure that you always read your writes. It does most of those things for you. We haven't used it, but it seems pretty promising. And the company that is behind this fork, called Turso, they also have managed cloud services. They recently actually announced that they allow you to sync your database to AWS S3 Express. So that's something you could look into if vertical scaling isn't enough for some reason for you. So to wrap it up, our journey, we went with SQLite because we were driven by the simplicity, by the promise of lower costs, because we were constrained on our development team's velocity. The result is that our application is faster. We slashed our costs quite a lot. We don't really need to deal with DevOps anymore. I think SQLite is actually pretty viable and beneficial. You can run it for many RISE apps in production. There are obviously some trade-offs. You need to make sure you understand them and that your application, that you're okay with them. But for us, I think it was a very good choice. So yeah, that's it.
Thank you, Wojtek. It's a really great talk. Oh, I'm going to.
Hello, thank you for your talk. I have a question because you didn't mention about the backups and how you are doing that and so on. So can you really?
Right. So actually, I had my initial version of the presentation had twice as many slides, and some of them were on backups. We are using two things actually. The first one is Lightstream, which replicates your database into. We use Cloudflare's R2, but you can also use AWS S3 or whatever you want, as long as it's compatible with S3. What it does, it replicates your. So we have it set up so it replicates every change every second, which means you have basically an exact copy of your database in your S3. And if you use R2 on Cloudflare, it's actually almost free because they don't charge you for many things. Actually, it's pretty useful because we can replicate our production or staging database into our development environment with one command, and in a few seconds we have all the data we need. And you can go back to any point. So we have it set up so it remembers last 48 hours. We can go back to any point in time in the last 48 hours. But other than that, we also run a simple script in a cron, which just runs. I mean, SQLite is just a database. It has this command called backup, which exports a database in a backup format. You can just tar it and put into your S3. So we have those few lines of code which we run every day to do like a separate full database backup.
Thank you. I have one more. Why you are not using solid queue just for migration with bunches? If some migration need to have a transaction and really heavy load.
Yeah, I mean, we probably can do that. Yeah, why not? I guess it depends a lot on what kind of transaction the migration you have. But yeah, that's probably one of the, that seems like a viable option. Thanks.
Thanks for your talk. Quick question, have you considered just running a local instance of Postgres? Sounds like that would save 80% of your headaches, and then you wouldn't have the migration issues and stuff like that.
All right, so there's a few things. So the first of all, there are some benefits for running SQLite, even if you were to run Postgres on the same machine, because SQLite runs in the same process, which means, so even if you were running it on the same machine in a separate server, each time you wanted, you try to get something from the database, your application has to serialize it. Even if you are using socket, it has to wire it over the socket to a different process. This process has to process the response and so on. So there is still some overhead, definitely more overhead than with SQLite, which means that N+1s would still have some overhead. Other than that, well, you still need to manage it. You still need to. SQLite is actually very easy to manage because it's meant to be run inside your process. It's built with the idea that it will be embedded. So you can. I mean, if you're not using a managed Postgres instance, you probably know of some of the headaches that comes from managing it on your own. Also, you would need to care about, with Postgres, you always have to care about the connection, like how many connections you have. If you have too many, you have to pull them somehow. There's a bunch of other issues that we would have to solve. And migration wasn't really that bad. Again, it took us 3 days for a single person. And everything is reversible. So if we don't like it, if we decide that SQLite isn't enough, actually, we can always just go back to Postgres.
Hi, first of all, great presentation, thank you.
Thanks.
And how long ago did you migrate? And have you ever regretted the decision?
So the first question was, how do you, I'm not sure.
How long ago did you migrate?
How long? Okay. I think it was like 3 months ago, something like that. Not that long ago. Did we regret it? Not really. I mean, the mere fact that everything is so much faster and we don't have to worry about performance. We had some issues with scaling our render, and the bill was getting pretty ridiculous for the amount of traffic we were having. Right now, we don't have to worry about it at all. Our application loads almost instantly. It's great. I guess the biggest regret was, I mean, the biggest frustration we had were with those foreign keys, which sounds silly, but debugging them, yeah, it was pretty annoying. No, we are very happy so far.
Wojtek, can we get a promise that if you start regretting that, you'll make a talk next year?
Sure.
Thank you.
Hi, great talk. What is the biggest table? How many records do you have there, and what's the total size of your database machine?
Right. So I don't know how many records we have, but our database isn't really that big right now. We have it's a little bit more than 1 gigabyte. Yeah.
So the biggest table, ballpark estimation.
You mean how many records?
In one table.
I don't know, maybe tens of thousands max. Something like that.
Okay, thanks.
Be the last one. So 2 hands simultaneously. Damn it. Race condition. I'm confused.
Okay, thank you for the great talk and great experience. Sharon, one note that you were mentioning a few times that n+1 are not an issue here, but and definitely there's smaller overhead on selects on database side, but still want to warn some people that there would be you are using active record, and there would be a massive overhead on memory allocation wise. So it's not like you're still not using EEP framework where there would be an orders of magnitude less memory allocation on models and overall different principles. I think you still have to deal with the same n+1 elimination like you would do in Postgres, so it doesn't change.
Right. So yeah, probably. I mean, we've run some tests for simple n+1s where we were just testing how it behaves with includes relation and without it for some requests, and the difference was negligible for most requests. But you still have to remember not to overfetch data. I mean, if you can't be reckless and just fetch all of the users from a database to find one record, right? But at least for those simple n+1 queries, in our tests, it wasn't really slower with or without n+1s. But yeah, you're probably, I mean, there is probably some overhead there.
Okay, thank you.
Okay, sorry, Wojtek, one more because I'm on good foot with Piotr and I don't want to lose that.
Hello, thank you for the talk. Could you tell how did you manage with existing data migration, and what was the downtime that you required to switch from one engine to another one?
Right, so existing data. We use this script. There was where it was. There's this open source script which does data migration. It was there somewhere, but we slightly modified it because there it is. We used this script basically. We slightly modified it because it was created database from scratch. We wanted to create our database through Rails to make sure that we were using the schema created by Rails. We basically removed a few lines from it, and since our schema was compatible with SQLite, since everything that we were using PostgreSQL was already available in SQLite, it just went through, and that was it. The downtime, it took us, I think we took down the app for like an hour or two, something like that. Yeah, that's it.
Cool. All right. Thank you very much, Wojtek.
Thanks.